Welcome back, everybody. Patrick here. We are moving on to another question. So this given graph, each letter on the graph represents a point on the function, between which points is the average rate of change, which I represented by this, is less than the average rate of change from points A to C, and then part B, which point has the greatest instantaneous rate of change. So let's start off with part A, between which points is the average rate of change less than the average rate of change from points A to C? Well, average rate of change from point A to C is going to be what? It's going to be the slope of the secant line, right? Average rate of change secant line. So we have to find two other points between which the average rate of change is going to be less than the average rate of change from A to C, meaning that the slope of the secant between those 2 points has to be less steep than the slope of the secant from A to C. So let's try a couple of points here. What about from point A to B? Well, if we make a secant line there, notice how it's going to have a pretty similar slope as A to C. So it's not obvious that it's going to have a average rate of change that is less than this average rate of change. What about from C to D? Well, notice how that's going to be a lot steeper than A to C, so that won't work. C to E may work, but it's not super obvious. However, one that is obvious is C to F, right? C to F, if we draw a secant, it's almost like a horizontal line, perhaps maybe slightly negatively sloped. But notice how this slope is a lot less steep than this slope. So it's obvious that from point C to F, the average rate of change is going to be less than the average rate of change from A to C, right? Because it has a less steep slope. So C to F is the obvious answer on this graph for part A. Again, C to E may work, even E to F may work, but you don't want to take the chance. So C to F for sure is going to have a smaller average rate of change than A to C. And then part B, which point has the greatest instantaneous rate of change? Well, when we're talking about instantaneous rate of change, what are we talking about? We're talking about the slope of the tangent, not the secant anymore, because it's only at one point. So which point on this function is going to have the steepest tangent? Well, we can just draw tangents for each point. So A is going to look something like that. Notice how B is going to look like that. It's going to be a horizontal line because it's a maximum. C will be like this. D will be, again, horizontal because it's a minimum. E will look something like this, and then F will be horizontal as well. So out of all of these, which one has the steepest slope? And remember, it doesn't matter whether it is sloped negatively or positively. Only the steepness matters. So perhaps point C, I would say. Maybe point A. Right? Maybe point A. But I would guess point C. Point E maybe, but this doesn't look as much of a drop as the interval B to D does. And C is almost like in the middle of B to D, and then with that steep drop there, if we draw that slope of the tangent, it's going to be fairly steep there. So in my opinion, point C is going to have the greatest instantaneous rate of change.